Okay, let's learn how to do dihybrid practice problems. Dihybrids are when we are tracking two traits that are not linked to each other. So just two different traits, and then we're looking to see in the offspring, what's the probability that the offspring has any sort of combination of those two traits. So in the first problem, we have some information about bacteria. The first thing they tell us is that in bacteria, an oval shape is dominant over round. Then the next part of the information says thick cell walls are dominant over thin. So that's two different traits we're looking at, shape and size. So we need two letters to show our different types of alleles for these traits. So an oval shape is dominant over round. Let's choose the letter A. So big A is oval, little a is round. The next trait is size. So thick cell walls are dominant over thin. Let's choose the letter B. So big B for thick, little b for thin. Then they give us information about our parents. It says cross a heterozygous oval thick cell wall bacteria. The heterozygous here applies to both of those traits. So heterozygous oval would be big A, little a. Thick cell wall, so heterozygous thick would be big B, little b. With a crossed with a round, thin cell walled bacteria. So to be round, that would be two little a's, and thin cell walled would be two little b's. Now we have to fill out our Punnett square, and if you notice, our Punnett square now has 16 squares. And the way that we're going to fill out our Punnett square shows the possible allele combinations for those particular traits. So we will be looking at the FOIL method to help us do this. So I'm going to write across the top here. We're going to put our first parents combinations of alleles across the top. So I'm going to write the letters F, O, I, L, just to remind us what combination of alleles we're putting up there. So over here, if we look at our first parent, FOIL is for first, outside, inside, last. So the first allele of both of the traits. So the first A and the first B. And I'm just going to mark up my paper like this so you can see where the F is coming from. So we're putting big A and big B over here. O is for outside. That's the outside allele. So literally the outside A and the outside B. So that is a big A and a little b. Inside alleles, that would be the inside A and the inside B. So little a, big B. And the last alleles, the last A and the last B on the outsides. So that would be big A and little b. Now we would do the same thing with our second parent down the side of our Punnett square. So I'm going to write the letters here, F, O, I, L. But if you notice, our second parent is all heterozygous. So the only possible combination of alleles we have for that is little a, little b. So we're going to have the same all the way down the side here. But if we had different alleles, we'd still do the FOIL method to figure out which alleles go where. First, outside, inside, last, just like we did with that first parent. So now all we have to do is to fill in our Punnett square. So we're just going to do the same thing that we've always done for Punnett squares. We look all the way to the top and all the way to the left to figure out what goes in the Punnett square. So we always, to keep these letters straight, since we started out with A's first, we're always write the A's first. So in this box, we have a big A on the top and a little a to the left. Okay, so that's what we're going to fill in our Punnett square. Big A, little a. For the B's, we have a big B and a little b. So we're going to fill that in as well. Now, if you notice on this left-hand side, we have all little a, little b going the whole way down our Punnett square. So our alleles that go in these boxes are going to all be the same the whole way down. So I'm not going to fill them in. I'm just going to draw an arrow to show that. Okay. In this box, we have a big A here and a little a over here. And we have a little b and a little b. And again, same way the whole way down. Little a, big B, little b. Same the whole way down. And then for this one, big A, little b, little b. Same thing the whole way down. Now the problem asks us to describe the phenotype of the offspring. So to do that, we're just going to look in our Punnett square, and then we're going to pick out what particular genotypes are possible. So in the first box here, I see we have the genotype big A, little b, little b. Then we have big A, little b, it's here. The next one we have is little a, big B, little b. And then we have big A, little b, little b. So it wants us to say the phenotype that each of these would be. So if we go back up to the top and we look at our key, it makes our life a little bit easier. So we know that this particular bacteria would be oval shape and thick. This guy would be also oval but thin. This guy would be round and thick. And this guy would be oval and thin. And then we could say the probability of our offspring being these would be, since they're the same the whole way down our Punnett square, we know we would have 1, 2, 3, 4 boxes being this first phenotype. So that would be 4 out of 16, or we know that's 25%. And that would be the same for all of the rest of these phenotypes as well.